Okay, good morning once again. Today we're going to start our new discussion on multiple regression. This will be the main topic that we will be focusing on for the rest of the term, and of course the other other topics on regression and time series. So we start with an introduction to regression. I shared with you an RMD file and a data file. Okay, kindly open the RMD file. So once you have it loaded in our project, you can easily copy it or open it. Okay, let me just close the outline. Okay. And then, sorry about the date. Baguhin na lang natin yung date, no? So this is May. Hindi ko ginamit dito yung our system. May 25, 2023. Introduction to multiple linear regression. Okay. All right. Once again, kindly chat, please, if you have the file opened already. Let's wait for the others. Only 8 out of 28 has signified that they have the file ready for discussion. Let's give others some time. If you just came in, I shared with you a file, Introduction to Regression workbook, and then also a CSV file. Then we opened our project file. We titled it Multiple Introduction to, number 2, Multiple Regression. And then we loaded those two files that I shared with you there so that it's easily accessible. Okay. All right. I hope most of you have gotten the file. Okay, so let's discuss this. Let's have a brief introduction to multiple linear regression. I'm sure you have met this in your other subjects. This is not something new to you. You have been exposed to several statistics subjects, not only in college, but also perhaps in your secondary school level. So multiple linear regression, otherwise known as multiple regression. Okay, what is it? Well, it's a statistical technique that we use in order to explain a variable of interest. So, for example, we want to explain, let's say, what factors or what parameters affect a person's, let's say, hourly wage. So it has been known that there are some factors that affect hourly wage, just like education, okay, or age, or number of years worked, or perhaps the location itself. Okay, so there are several variables that can affect the hourly wage that a person earns. And if we set out to discover or to try to explain what these factors are, and if they're statistically significant predictors or explanatory variables in trying to describe our variable of interest, which is our hourly wage, then that process is called multiple regression. So gusto natin malaman kung may relationship ba yung dependent variable natin, which is our explained variable, okay, our dependent variable as explained by our independent variables. Okay? Our explanatory variables. All right. So what's the goal of multiple linear regression or multiple regression, it's to establish a relationship between your dependent variable or response variable or outcome variable with the other variables called explanatory variables or independent variables. The method that's used here in explaining in coming up with a model is called the least squares model or the ordinary least squares. We'll try to explain how this is conducted as we go along. So it's called the ordinary least squares or OLS. Take note of the word least. It's not L-I-S-T, it's L-E-A-S-T. All right. Now, the formula that we use in explaining this equation can be found here. Now, if you note, so this is the first time that you're seeing this. Okay. This is called your LaTeX. That's your LaTeX code. And the LaTeX code is used in order to write text or write mathematical equations. And there are certain rules in dali class medyo na ano ko. There are certain rules as regards using the LaTeX in writing text or mathematical equations in R. Okay, if you take a look at this, we'll just briefly look at some of the codes here, and we will not you're not going to learn this overnight. It takes time, no? So itong slash begin align. Okay, so this is how the text below will be written. Okay, so this indicates that this is the beginning and meron tayong ending dito and aligned pa rin. If you can see the output, they're all aligned, no? So this is how you align the output. Now, learning LaTeX is very important. It's very good also to learn this skill. Because if you're going to write a report, if you're going to write your research paper, if you're going to write, let's say, a book, gamit na gamit talaga itong LaTeX na to. Okay, so, yan ang simula, no? Begin, aligned, and align. If you can see the output, aligned siya. Okay, and then it starts with this one. And, take note of this, y underscore I. Y underscore I, the underscore here refers to the subscript. If you take a look at this, no, naka-subscript siya dito. Okay, y underscore I, okay, is equal to, and then here you have your slash beta underscore 0. The slash here, and then beta indicates that this should be a Greek letter. Yan, kaya tingnan nyo, yun ang ibig sabihin nun, yung slash beta. So the slash here, if you want to write the Greek letters like gamma, alpha, etc., you have to use the slash and then the Greek letter. And then again, may underscore dito. No? Sabi natin kanina, pag may underscore dito, it can mean a lot. One of which is to be a subscript. Yan. Kaya tinan nyo, beta underscore 0, you have this. Okay, and then you have plus, again, beta underscore 1. And then you have this x underscore, tas dalawa yung subscript niya, I1. Okay, so if you have two subscripts, then you have to put it in curly brackets there. Okay, that's how you write now b beta 1 times x I sub 1. Okay, I sub 1. And then etc. Okay, until you have this. Okay, ito slash epsilon, the Greek letter epsilon, and then underscore I. Okay, so I just want to explain the first line here. which is this one. Okay, and then as we go on class, you're going to be exposed to uh, other uh, other forms of LaTeX, no? Ito continuation lang. Itong dalawang to, no? It means that you have to start with another line. So, dalawang slash, and then end. All right. Here we have slash and then text, bold face, no? Kaya kung tingnan nyo dito, yung bold, yung where, naka-bold siya. Okay, bold face yung where for I is equal to N, and then text bold face again, observations. Yeah. This line is writing this one. Okay, etc., etc., etc. Plus. Okay, so this is the output of this LaTeX notation. And as I said, class, kasi kunyari sa mga journal, sa mga research outputs, mahirap kaya isulat yung mga ganyan, yung mga equations. So there was developed this system called LaTeX so that it becomes easier to write yung mga equations na to, okay, etc. Okay. Okay, any questions so far, class? Paki-chat nga please kung okay naman tayo so far. Okay, of course, when I say okay, I don't mean na naintindihan nyo na lahat ton. Okay, it will take time, class. But at least yung simula, na-expose na kayo, na may LaTeX pala. And sa paper output namin sa subject na to, I can construct this pala so that hindi pangit yung kakalabasan na output. Pwede palang ganito na malinis yung pagsulat ng equation, pag-align sa kanya, pagsulat ng Greek letters, etc. Okay? All right. So, of course, nobody's preventing you from doing research on LaTeX and really finding tips on how to write that. I expect, class, that your output in your first case will be done yung RStudio nyo or either Quarto document using LaTeX codes like this para gumanda yung output. Okay. Now there are assumptions as far as multiple linear regression is concerned. Okay, so what are the assumptions? Let's take a look at the assumptions one by one. Number one, dapat linear yung data natin. When you say linearity of the data, the relationship between your variables should be linear. And when we say linearity, what we want is that the relationship between your independent variable and your dependent variable should be linear. Okay, take note, I'm saying the relationship between your dependent and your independent variable. Okay, why is this so? Okay, let me annotate that a bit. So mag-annotate lang ako. Okay. Suppose we have this, okay? So this is your y-axis, this is your dependent variable, and this is your x-axis, this is your independent variable. If you're going to make use of x in order to explain y, okay, dapat talaga, pag prinat natin siya, dapat there should be a semblance of linearity. Yan, ganyan, kunyari, yan, no? Okay, so if y and x and y behave this way, ito yung relationship nila, then we will be able to create a model, okay, and predict. No? So this is a regression line that explains your dependent variable via the independent variable. Okay, and it appears to be quite linear. No? Now, unlike, let me create another one here. Okay, let's suppose we have another variable, y and x1, and their relationship is like this. When we plot them, ganito yung relationship nila. Okay. So it will be foolhardy, class, to use a linear regression to try to establish the relationship between X and Y. Kasi obviously, yung relationship ni ni X and Y dito, hindi linear. It cannot be explained by a linear model, but rather more of a quadratic, a, okay, pwedeng quadratic, no? A non-linear model. So, this is what we mean by linearity of the data. Dapat, if we're going to use ordinary least squares in explaining your variable y via the variable x, if you plot them, if we create a scatter plot out of them, it should have a relationship like this, and not one like this. Neither one like, for example, like this. Kunyari, ganyan, may sinusoidal na relationship. Hindi pa pwede yun, no? Hindi tayo magsasucceed kung gamitin natin yung linear model in order to explain your dependent variable. Or if it was like this, kunyari, may gantong pattern siya, di ba? So this is more exponential. A small increase in x leads to a very huge increase in y. So if you use a linear model for this, hindi magiging maganda. So generally, we use multiple linear regression if the relationship between your variables of interest are indeed linear. Kaya nga ang tawag natin linear regression. So kung hindi linear relationship niya, then that means that there is another model that should suffice for that. Okay? So very basic yan, class, no? So that's why basic din na kailangan ipa-plot natin yung data. Tingnan natin. Linear ba yung relationship nila? Kung hindi, kung it looks like more quadratic, and then, so spare yourself of the trouble of using a linear regression. It might call for another model, no? Hindi linear. Okay, now also take note that the linear relationship has to be between your dependent and your independent. Okay, we're not asking here about the linear relationship of two independent variables. Okay, di na, kasi kunyari kung marami tayong independent variables, we have x1, kunyari hourly wage, ano? So what can explain hourly wage? It can be education. Okay, ano pa? It can be, say, years of experience. Pwede rin. Okay? Or it can be the region where you're coming from. X3. Okay? So, we want these variables to be related linearly to your Y, to your hourly wage. But we don't want that education will be related to yung years of experience, for example. Ayaw natin na yung independent variables natin are strongly correlated, highly correlated. Why is that so? Because, as we'll be explaining in a while, magkakaroon tayo ng problem in as far as determining or segregating the impact of x1 on y and the impact of x2 and y. If they're highly correlated, then mahihirapan yung model natin na i-segregate, no? Yung ano yung impact ni x1 on y and ano yung impact ni x2 on y. Okay? They will compete with each other in explaining why. And this is a condition called multicollinearity. And we don't want multicollinearity in our model. Okay? So, yung linearity na, yung assumption number 1, dapat linear yung relationship ni x at saka ni y. Yung independent variable at saka yung dependent variable. Okay? But not the linear relationship of your independent variables. As much as possible, we want the independent variables to be not related. Again, the problem is, kung highly related sila, highly correlated sila, then ang tanong doon, kailangan pa ba ng dalawang variable na yan? Kung halos pareho lang naman yung movement nila, halos pareho lang pag-explain nila kay y, and then, based on the principle of parsimony, when you say parsimony, the lesser the regressors, the lesser the explanatory variables, the better. Okay, bakit pa natin isasama yung dalawa? kung pwede naman pala natin isama si X1 na lang or si X2. Diba? It will make our model simpler, and that's what we want, a more simple model, a simpler model. Okay? We don't want a model where you have 100 explanatory variables. And we'll explain that later, no? Kasi tataas yung coefficient of determination, and that's true. Kaso yung adjusted R-square niya bababa. And chances are, class, merong magkakaroon dyan ng multi-collinearity. Yung the independent variables would compete against each other in explaining your dependent variable. And that might create a problem because we don't know now how to split yung effect ni X1 on Y and X on Y and other variables. Okay? So let me pause for a while. May I ask class if so far clear yung discussion natin sa first assumption, yung linearity of the data. Kindly chat, please. If you have any questions, please feel free to unmute yourself or chat. Di pa lang. Waiting for your responses, class. Okay, thank you, class. As I said, I really appreciate your feedback so that I know that you're able to follow along. Okay. Wala naman nag-question, ano?
Sir, I asked a question.
Ay, sorry. May nag-question ba?
Okay.
Okay. Ano yung question? Ito. So, Rui, the question po, since di ko po ma-picture yung quadratic data, Rui, kindly share your question to everyone, please, para hindi ko nabasahin. Share mo na, Rui, yung question mo? Okay. All right. So, thank you, Rui, for this question. Since di ko po ma-picture yung quadratic data, if linear data na independent variables, age, work experience, ano po example ng quadratic data? Okay. So, yung quadratic data, ang ibig sabihin nun, same data lang, no? Kunyari, experience at saka yung hourly wage. So, when you plotted experience at saka hourly wage, ganito lumalabas sa data natin. Example lang to, So, let me choose again this yellow. So, pre-not natin, no? Yellow ba yun? Hindi. Okay, I'll plot. So, pre-not ko si experience as si hourly wage, yung Y, ito. And ito si experience, X. Okay. And then lumalabas na, say, ang preponderance ng data natin pag ganito. So, it has something to do with the data that you collected. Tapos ganito siya. Ganito yung lumabas when you plotted. Okay, ibig sabihin nun, there were some who yung X nila mababa, yung number of years experience, tapos yung hourly wage nila ito. Tapos meron dito mataas yung years of experience nila, pero yung hourly wage nila pareho lang din dito. Okay? So if you take a look at this, may mga points na mababa yung experience, yung years of experience, ito yung hourly wage level. Meron namang mga mataas yung years of work, tapos yung hourly wage nila ganito. So if your data behaves like this, then hindi ka pwedeng mag-linear regression dyan. Kasi yung relationship mo ng Y at saka ng X mo, hindi naman linear. It's more quadratic. So if you're going to try to predict Y based on your years of experience, ang gagamitin mong model hindi linear. Okay? So malamang baka quadratic regression yan. Yan, ganyan yung magiging model natin. So this is definitely not a linear model. Okay, so it depends on the data, no? I'm not saying that experience has a quadratic relationship with hourly wage. It depends on the data. So kunyari, nag-research tayo sa isang particular area, tapos ganun yung nakuha nating data. Then in that case, quadratic yung relationship nila. Pero in another area, hindi naman ganun. Linear naman yung lumalabas. No? So, dun sa case na yun, na linear yung relationship nila, then pwede tayo mag-linear regression. Okay, I'm not saying that experience is always linear. Hindi ganon. Ang sinasabi ko, depende dun sa data na nakuha natin. Okay? So, pwede yung work experience, pwede yung education, that can act as a quote-unquote non-linear predictor of your hourly wage. Depende dun sa data natin. Okay, Rui, did that answer your question?
Yes, sir. Gets na po. Thank
Okay,
you.
sige. Ano po example ng quadratic data? Okay. So yung quadratic data, it can be any data. So depende yun sa sa relationship, yung sa pag-plot, yung sa natin, sa data natin makuha. Okay, clear ko lang to, no? Clear all drawings. All right. Okay. So that's the first assumption. Dapat linearity of the data. Okay, sabi ko nga dito, a simple way to check this is by producing scatter plots. I-plot natin, di ba? There's nothing beats a visual also representation. Kasi hindi naman natin pwedeng tingnan yung data ng table, yung data frame, tapos ay, mukhang linear siya. Unless napaplot mo visually kagad based on the data frame lang. So that's virtually impossible. So you have to do a scatter plot. Number 2, linearity of the parameters. So hindi lang yung linearity of the data, yung relationship ng x at saka y. Okay? And take note again, reminder, hindi x on x, it's x on y. We don't want x to be highly correlated with x. We don't want that the predictors have a high correlation. Ayaw natin yun kasi, as I said, and I hope I don't keep on repeating this, but this is some aspect that we really need to understand. Ayaw natin na highly correlated yung mga independent variables natin because that might lead to what we call multi-collinearity. All right, linearity of the parameters. So, ang ibig sabihin nito, class, that the parameters, okay, the parameters refer to the coefficients that will be generated by the model should be linear. Okay, should be linear. Take note, it does not require the model to be linear in variables. Let me explain that. Okay, take a look at this. Okay, you have here this model, y sub I is equal to beta null, beta 1 squared, beta 2, beta plus, etc., beta sub n. This, yung beta null, beta 1, beta 2, up to beta n, these are called your parameters. Ito yung sinasabi dito. Yung linear in parameters. Now, okay, so this is how you wrote this, no? Ito yung LaTeX natin dito, no? So, this tells us that hindi pwede na yung parameters natin is nonlinear. Take note of this. Beta 1 squared siya. Okay? So, hindi pwede to, class, kasi mahirap isolve to. You cannot create a multiple linear regression using OLS where the parameters are nonlinear. So, hindi pwedeng naka-square root si beta 1 or si beta 2 naka-log or si beta 2, beta n sub n naka 1 over beta sub n. So, hindi pwede yun. Okay? When you're doing multiple linear regression, it should be only beta 1, beta 2, beta 3, up to beta n. Hindi pwede ito because this is not linear in the parameters. Hindi pwede si log of beta 3. Kunyari, hindi pwede yan kasi hindi naka-linear si beta 3. Hindi pwedeng 1 over beta sub n. Hindi rin pwede yan. Okay? We cannot use these types of model for an OLS, ordinary least squares. Hindi rin pwede yung square root of beta sub n. Hindi pwede because this is similar to beta to the 1/2. Hindi pa pwede yung naka-raise sa exponent yung betas natin. Hindi pa pwedeng 1/2, 1/3, hindi pa pwedeng 2, 3, 4, 5. Kailangan to the first power lang yun. Okay? That's what we mean by linearity in parameters. Okay? So, please take note of that. That's very important. In order for OLS to work, the specified model has to be linear in parameters. Okay? Note, if the true relationship between x1, which is your coefficient ng beta 1, and y is nonlinear, hindi natin pwedeng ma-estimate yung coefficient in any meaningful way. Okay? It will be difficult to explain what beta 1 is using ordinary least squares. On the other hand, ito, class, tingnan nyo to. Ito pa pwede to. So pwedeng y sub I is equal to beta null plus beta 1. Whatever your x is, pwede naka-square yan, pwede naka-square root yan, pwede naka 1 over x yan, pwede naka-log yan. It doesn't matter. We can create a model out of that, no? An OLS. Okay? So, sabi nga natin dito, assumption 2 of the class CLRM stands for classical linear regression model, requires the model to be linear in parameters and not in the predictors. OLS is not able to estimate equation 1 in any meaningful way if the parameters are not linear. However, assumption 2 does not require the model to be linear in variables. Okay? Hindi natin pinagtataluhan kung yung x mo squared, x mo square root, x mo nakalog, pwede yun. Okay? Mako-compute pa rin natin yung mga parameters natin, si beta 1, beta 2, etc. Using ordinary least squares. Okay, pause muna ako, class. I hope that's clear. May I have your feedback if you were able to get conceptually the first two assumptions?
Sir, so bali, how do you quantify y? Like, is it a percentage rate of change or is it an actual value?
Which one?
For y dependent variable with what you're explaining in the discussion, sir? Because I don't
Depende.
understand kasi, sir, how
Yeah.
yung like for beta dependent variables are different quantifiers, sir. Like yung isa income tas yung isa time. So like how do you anong final value ng y then?
Yung final value ng y, you mean to say the predicted value?
Yes, sir. So ang lalabas ba dyan, is it a numerical value in itself or is it a percentage rate of change?
Okay, good question, no? Y has to be quantitative, no? Hindi siya pwedeng logical value, hindi siya pwedeng binary like 0 or 1. Sa multiple linear regression, ang assumption natin, y is a quantitative value. So it doesn't matter kung percentage siya. Si y din pwede ding ilog yan. Okay? As long as si y is quantitative. Now, of course, mayroon tayong dalawang values ni y. The first one is the actual value. Kasi kunyari nag-research tayo, no? Kinuha natin yung value. Kunyari, let's go to a certain place, nag-random checking tayo, tinanong natin yung tao, ano yung hourly wage mo? Okay, so meron siyang value na yun, no? Ano yung years of education mo? ano yung years of experience mo? Ano yung gender mo? Okay, so meron tayong actual values. Based on our survey, based on our research, meron tayong actual na value ni y. Right? Do you follow, class? Hello?
Bale, sir, okay, so you're talking about multiple variable?
Oo. Okay, balik tayo sa example natin, no? Ang variable of interest natin, hourly wage, no? Saan mo makukuha yung data na yan? Siyempre, magsisurvey ka, magre-research ka, tatanungin mo tao, ano yung hourly wage mo? Okay, kunyari, ang hourly wage niya, 1,000 pesos per hour. So, why yun? Why sub I yun? Yun ang value ng hourly wage niya. But when you survey, tatanungin mo rin, ilang yung years of experience mo? My years of experience is 20 years of experience. Tapos, ano yung education, years of education? My years of education is 10 years. Example lang yon. So, di ba may value ka ng Y sub I, may value ka ng hourly wage. Di ba? Yun muna, yung actual value muna. Are you getting me, class? Saan nanggagaling Y sub I na yan? Sa survey natin. Sa pagkuha natin ng data, pag-gather natin ng data. Right? It's not something that you compute. It's something that you get by survey. Class, tama?
Okay,
Hello?
understood, sir.
Okay, now, meron na tayong value ng education, meron tayong value ng experience. Tapos meron tayong 100 respondents. Okay? Ngayon ang gusto natin, makakagawa kaya tayo ng ng model para ma-predict natin yung hourly wage based on experience, based on education. So ang gagawin natin, meron tayong 100 observations, andun lahat ng Y sub I, andun lahat ng X sub 1 mo, andun lahat ng X sub 2. From that data, we will now compute for ano yung value ng beta null, beta 1, beta 2, yung mga parameters natin. Okay? So, once we model that, magkakaroon tayo ng value ng beta 1, beta 2, beta 3, right? Tapos, what do we do now? We can now predict your Y sub I. So, for example, if a person has 10 years of experience, if it has 20 years of working experience, ano yung magiging predicted value ni Y? Okay, so we can now predict the value of Y based on the model. Okay, so yung actual value ni Y, that will be based on your research, kung saan natin kukunin yung data natin from your survey. No? Yung predicted value ni Y will be based on the value that we're getting, yung model value natin. No? Tapos yung difference niya, okay, ang difference niya will be what we call the residual. Kasi yung model natin oftentimes will not give us the exact actual value. We will see this when we have an example in a while. Okay, did that answer your question? Sino nagtanong na yun?
Clear, sir.
Sam?
Understood.
Sam, clear ba? Sam, clear?
Clear, sir.
Okay. So, yung yung question mo is more of the how to get the value of Y or ano? I hope na tama yung pag-answer ko nun.
Yung only the final value, sir. If we're expecting an actual whole number, or are we expecting a percentage rate of change, or is it a function in itself?
Depende yon, no? Kasi depende yung value ng Y sub I mo eh. Kasi Y sub I can be a percentage of your X. Your Y sub I can be a whole number. So it really depends on the and you can, kunyari whole number siya, pwede mo siyang gawing marginal percentage by getting the log of that. But those are special cases which we're going to discuss as we go along. No, hindi pa ngayon. No? In a few weeks time from now, magkakaroon tayo ng model na log yung Y, log yung X, okay, etc. So these are special cases where the values of Y are different. Hindi lang siya yung quantitative na na simple lang. Pwede kasi natin kunin yung log ni X, ni Y. Pwede mo rin kunin yung square root niyan, no? It really depends on the requirement of the model. Okay, so I hope that answered your question, Sam.
Yes, sir.
Okay.
Understood.
All right. So third assumption is that yung residuals natin dapat homogeneous. Ano ibig sabihin ng homogeneous? Dapat yung behavior ng natin ng residuals hindi dapat siya yung variance siya hindi dapat nagdi-disperse, no? So let me illustrate that via a diagram. So homogeneity, 'di ba, pag sinabing homogeneous, same, no? Equally. Okay? Equally spread dapat yung natin, yung variance natin. Variance ng residuals. I mentioned a while ago dun sa question ni Sam na dalawang values ni Y ang makukuha natin dito, no? So what are those two values? The first value is yung actual value. So meron tayo niyan, di ba? We have that value. Where did we get this actual value? From the survey, from the research. And then meron tayong what we call the predicted value or the model value. Ang tawag natin dyan Y hat. Okay? Saan natin ito makukuha? We can get this by, after we get the values of the parameters, yung model natin, okay? Then we get the actual values of your independent variables and then plug the parameters there. Mamaya papakita natin to So beta null plus beta 1 times x1 plus beta 2 times x2, etc. So pag kinompute natin yan, we will get what we call the predicted value or the model value. And for example, yung predicted value ng hourly wage ko is 20. Tapos based on the model, ang nakuha ko lang 18.5. Okay, so in this case, we can see that our model understates our actual value. Kasi yung model natin 18.5 lang, ang actual value natin 20. And if you get the difference, it's 1.5. That difference between the actual value and the predicted value is called your residual. E sub I. Yan ang residual natin. Yun yung error natin. Okay, but technically, it's called residual. Okay, but for layman, mas madali ma-conceptualize kasi yung error. It means that hindi natin perfectly nakuha yung actual value natin. Some errors, some residuals may be zero. No? Ibig sabihin, tama yung pag-predict niya. Some residuals may be very, very high. Ibig sabihin, malayo. Okay, positively or negatively. So, ibig sabihin, pwede itong, kunyari, naging 40 to. Yung predicted value natin, 40. Yung actual value niya, 20. O, sabihin natin 30, no? So, ibig sabihin, 20 minus 30, negative 10. Ibig sabihin nun, we overstated, no? Overestimated yung hourly wage. Okay. So, when we plot the residuals, kunyari, ito yung residuals natin, no? E. Tapos, along the values of X, sometimes along the values of your fitted values. So, iba't ibang plots ang pwede natin gawin dyan. Okay? Dapat yung model natin, dapat yung residuals niya, ganito. No? Okay, what do you notice about this? Yung plot ng residuals, E, at saka yung value ni X. You notice that, okay, wala siyang trend. Wala siyang pataas o pababa. Hindi siya gumagalaw pataas. It doesn't move up. It doesn't move down. It does not have a trend. All right? In other words, class, constant yung mean niya. Mean is constant. Yung average ng residuals natin, constant. What else? Yung residuals natin, they move along this constant band. No? Itong band na to. Andito lang siya. No? So indicating that this has constant standard deviation or constant variance. Sigma squared or S squared. So constant lang yung variance niya, constant yung mean. Okay, this is what we mean by constant mean, constant variance. Therefore, ang tawag dito, homoscedastic. Homoscedastic yung variance natin. Okay, after you have a model, you don't stop there. You have to check for the residuals. Residuals play an important role. Kasi, kung yung behavior na residuals natin, let's say, ganito siya. If it was, on the other hand, this way, okay, take a look at this, class. What do you notice about the pattern of the residuals? Number one, hindi na siya constant, no? Okay, hindi na siya constant. Now, possible na may trend siya, medyo possible na tumataas siya. So, hindi siya constant sa mean, pero apparently dito, hindi siya constant in variance. Kasi, why? Why, class? At this point, okay, ang variance niya ito na. Ganyan nakalaking variance niya. Oh. At this point, dito lang. As we go higher and higher with your X, tumataas yung variation niya. No? Alright, so this is what we call non-constancy in terms of variance. Pwede siyang constant in mean kasi if you get the average, no? Baka pwedeng dito pa rin siya, no? Yung average, kahit na mataas at saka mababa dito. But definitely, it's not constant in variance. So if you have a case like this, then we say that our residuals are heteroskedastic. No? Hetero. Yung isa kanina, homoskedastic. Ito naman, heteroskedastic. Skedastic, which means, sorry for the writing, heteroskedastic, other spread out yung skedastic. Ibig sabihin, hindi constant yung, non-constant yung spreading out ng residuals natin. And in order for your linear model to be acceptable, clear drawings ko muna, X ko muna, para maging acceptable yung ano natin, yung model natin, kailangan homogeneous yung ano natin, residuals, yung variance niya. It cannot be heterogeneous. As we said a while ago, ang tawag, kapag homogeneous, ang tawag dyan, homoskedastic. Kapag heterogeneous yung residuals natin, yung residuals niya, yung variance niya, it's called heteroskedastic. So heteroskedasticity is one of the critical points as far as modeling in OLS, ordinary least squares, is concerned. Okay, so we will have to check that. Pagkatapos natin mag-model, kailangan i-check kagad yung ano, yung mga assumptions. Hindi pa pwedeng nag-model tayo, tapos sabihin natin, ay, tapos na. Okay na yung model natin. No, far from it. Kailangan mag-check muna tayo ng assumptions ng classical linear regression model natin. Okay. Now, yung number 4 is related to number 5, no? Independence of the error terms of the residuals. Kasi pag independent siya class, chances are magkaka-trend yan. Let me illustrate that. That's easily explained. Okay. Pag independent, pag non-independent or dependent yung mga residuals, pag prinat mo yan, so for example, itong residual na to will depend, the next residual will be dependent on this one. It will be dependent on this one. So there will be, mangyayari yan, pwedeng mag-trend na pataas. Okay, kasi pataas yung previously, pataas din ako. So pwedeng ganyan yung ano, yung residuals natin. Okay? So para magpo-form siya ng line, ba? Eh sabi natin dapat yung residuals natin constant yung average niya. Dapat ganito lang. Okay? Ito may trend. Or it can be also going down, no? Pwedeng pababa. And this happens when your residuals are dependent on each other. Okay, bakit naging dependent? Kasi yung previous pataas, tataas din ako. Yung previous tataas din ako. So, parang may ano siya, may tsunami effect, no? To put it bluntly. At tumaas yung previous 2 days, tumaas yung previous 3 days, tataas din ako. So that's what we mean by independence. Pag hindi siya dependence, no? Pag independent siya, walang pakialam, no? Walang pakialam yung mga residuals kahit na chronologically siya yung kasunod ko. Okay? It doesn't matter, no? It doesn't matter kung magkakasunod kami. My residual is not affected by the residual of the previous value. All right? So that's what we mean by independence of residual terms. So itong number 4 na to is actually connected with number 3. So that I should have placed that with number 3. Okay. All right. Next. Explanatory variables, balik tayo dito, are not collinear. Ito yung sinasabi ko kanina, no? It's important that the explained variable, the dependent variable, to be correlated, to be collinear with the explanatory variable or independent variable. That's very important. Kasi kung wala silang relationship, then what for na mag-create tayo ng linear model? If you cannot predict y by the values of x, and that happens when there's no correlation between them, then there's no sense in using multiple linear regression to explain your x Your Y pala, sorry. So ang assumption dito sa multiple linear regression sa OLS is that yung sa number 1 kanina, linear siya, di ba? So therefore, yung dependent variable and independent variables are possibly highly correlated. Pero si independent variables are not collinear. Ito yung sinasabi ko kanina, no? Otherwise, we will fall under a multicollinearity let's say violation. This is essentially the assumption that the predictors are not too highly correlated with one another. So kailan nagkakaroon ng multicollinearity? When two or more of the explanatory variables are highly correlated. It is a problem. Kasi mahihirapan tayo, as I said a while ago, we will be hard put to disentangle the effects of one variable with another. Ang tanong kasi dyan, dapat kasi may mga unique contribution yung mga explanatory variables. So paano natin masasabi na let's say 30% of the variation of your dependent variable can be explained by X1 and 20% can be explained by X2. If they're multicollinear, if they're highly correlated, hindi natin pwedeng ma-disentangle, mahihirapan tayo. Okay? Also, kung highly correlated sila, baka ibig sabihin nun, they're just explaining the same thing about your dependent variable. Ergo, might as well remove one of them. Okay, and lastly, we have here, dapat yung residuals natin dapat normally distributed. The residual errors are normally distributed. Again, we will explain that. And there are tests that we can conduct to see if the residuals are normally distributed. And kindly explore the reason why this is very important. Although hindi naman siya strict requirement, especially when you have a huge data. No? Pag malaki yung data natin, it doesn't matter kung normally distributed yung residuals. Okay? So let me see, I gave here some, paki-check nga natin to class. Control C, and let me see kung ano yung sinare ko sa inyo na ano dito na sites. Okay, dito ano? Kay Albert. Okay. And these are more explanations on key assumptions of OLS, ordinary least squares, econometrics review. Okay, so pakibasa siya, class. Ayan. Ito yung mga example, no? Okay. This is what we discussed a while ago, pero ito may mga mathematical na explanation. Alright, this is what I was saying a while ago. Ito yung heteroskedastic. The residuals are, ito constant in mean. Okay? Constant in mean siya. Di ba kasi, if you get the average here at these points, dito pa rin yung average, no? Dito pa rin yung average. Pero, hindi na siya constant in variance. Kasi you notice the variance is increasing over time. Diba? Dito yung variance, itong level na to. Dito yung variance, ganito lang. Same thing here, no? So non-constant in variance as compared against this one, which is constant in mean, constant in variance. Ito yung gusto natin that our residuals should be once we plot them. Okay? All right, so please read this as an additional material for you. Okay, tingnan natin itong isa pa. Let's take a look at this. Control C and Control V. Of course, there are other sources of information. Is this still live? Okay. So this is a package. This is a software, yung JMP. Okay, so may explanation dito ng okay, dito siya, no? Multiple linear regression, tapos fitting the multiple linear regression. Okay. Although konti lang, pero may mga ano din, may mga valuable na inputs. All right, so I leave that to you for your perusal. Okay, so going back to our notes. Okay, so this is what I was telling a while ago. Yung least square lines. All right? So ito yung observed value natin. Ito yung actual value minus the predicted value, which is this one. Y sub I, yung actual value minus Y hat sub I. Hat means predicted value. Okay, and it's equal, the difference is called your residuals. Okay, inulit lang dito. Okay, now, I just want to point out here that yung model natin is called ordinary least squares. No? Ordinary least squares. Ano ibig sabihin ng least squares? Okay, let me put that now here. What's the meaning of least squares? Bakit sa least squares? Okay, let me once again draw a, let's diagram that. So ito yung ano natin, yung y. Ito yung x natin. Plinat natin siya, no? We did a scatter plot, and it turns out that this is the scatter plot. Okay, so the question is, ano yung line of best fit? We call it the line of best fit. What line best describes your data? So if I plot a line here, sorry, medyo hindi tama yung ano. No? So let's say this is our linear regression. This is our line of best fit. This is our OLS. Okay, ano yung nature nito, nitong OLS na to? Okay, what we do is to compare. So this is your, okay, burahin ko nga kasi ang pangit ng pagkasulat ko naman. Yan. And then let me, oops. Saan si, tayo. Ano yung maan ba? Clear ko muna. No? Okay. Again, class. So this is our y, this is our x, and then we plotted scatter plot tayo. Ito yung lumabas sa scatter plot. So mukhang okay naman dito yung ordinary least squares kasi they seem to form a linear relationship. Tapos let me draw this. So let's assume this is the line of best fit. This is the ordinary least squares. Now, ang question kasi, paano na-determine to? Okay, so first, let me describe the dotted lines are your observed values. They're your actual values. The line here, this is your predicted value. So yung mga points dito sa line na to, sorry, hindi siya straight, no? Yung mga points, assuming na straight siya, yung mga points na yan, they are what we call your predicted values. Nasa line siya, yung mga predicted values natin. So if you take a look at this one, ito, this is what you now call your residual. This is your E sub I. It's a difference between your predicted value, ito yung line na to, and your actual value. So ito mga to, class, ito mga to, lahat ng mga points natin may mga residuals yan. Except for those points that are, let's say, were perfectly predicted. Okay, so nasa line sila. Yan. So yung mga lines na yan, the difference between your actual points and your predicted line, okay, is called your residual. Now, tanong, what happens if I add all the residuals? What do you think I will get? If I add those distances, the vertical distance between your actual data point and your residual, what happens, class? What do I get? I get what? What did you learn in your previous stat subjects? Anyone? If I add up all the residuals, assuming this is our regression line, if I add all the residuals, class, the answer is going to be, answer class is, yes, thank you, Celine. It will be a big fat zero. Zero, class. Zero yan. Yan ang regression line, no? Zero siya. Okay, yung mga nasa positive, yung y mo is greater than your y hat. Okay? And yung mga negative, when you add them, they will all add up to zero. That's why we don't use this. Hindi natin kinukuha as a basis yung errors, no? Ang ginagamit natin is, and most probably you guessed it right, we get the summation of your errors squared. Okay? Okay? That's where we get these squares, no? Least squares. And this line, this linear regression line, which is the line of best fit, is a line where if you add all the residuals, siya yung pinaka-least. Pinaka-minimum. Minimum siya. There is no other regression line, okay, where when you add all the residuals, will have a lower squared, sum of squared ng residuals. Okay, kunyari, andito yung ginawa mo regression. Edi, ang lalaki ng ano niyan, di ba? Ang lalaki ng mga residuals, square mo pa yan. So it will be definitely the residuals, if you were using this line, the residuals of this line will be, the squared residuals will be much, much higher than the one here. Okay, and this line of best fit is unique, no? Unique siya, class, ha? Sui Henry siya, na? Sui. Okay, ang hirap magano. Sui Henrys. What's the meaning of that? One of a kind yan. Okay? One of a kind yan. Yung sui Henrys yan. Yung line na yan. There can only be one line. That's the line of best fit. Hindi tayo pwede magka-line na ganito. Hindi pwede yan. Hindi pwede ito. There is only one unique line. Okay? I hope you remember that. Wala nang ibang line. Kaya nga, makakapag-generate talaga si R, or for that matter, any software ng isang model for your parameters. Kasi iisa lang talaga yung value ng OLS natin. If you compare that with another values of the parameters, the residual squared of the other will be much higher or higher than yung line of best fit. Okay. All right. So, punta tayo dito sa properties, no? Lahat panay ano tayo ngayon, no? Panay aabot tayo dito siguro sa importing wage para next meeting. All right. First, properties of the linear regression line. All right. The linear regression line goes to the center of the mass point. What do you mean by that? Okay. So, balik tayo sa illustration natin. Ito ulit yung plot natin, class. Ito si Y, ito si X, okay? Ito yung plots natin. Okay? And then if you get the average of X, si Y bar. So, dito yun. You get the average of X and the average of Y. Okay? Let's call this, ito. This one is X bar, Y bar. Okay, this point, no? This is Y bar. This is X bar. Bar means average, no? Plus. And then, if we create a linear regression model, it will always, without fail, always pass through this one. Okay? the linear regression model will always pass through the mean of x and the mean of y. Okay, clear dito class? Paki-chat naman please. Kung so far nakahabol tayo dun sa sa properties ng list. Take note, list, no? Actually, I forgot to mention a while ago. Sorry, ha? Diba ito yung mga residuals natin? Okay, ito. Yan, residual yan, diba? So, OLS will square this residual. Squared, no? Ito, so lahat ng mga residuals, square niya, konti lang. Okay, basta lahat ng mga residuals, ito square niyan, di ba? And then i-add natin yung mga squares niyan. And the line of best fit is the line that has the smallest least, the smallest na least pa, the least squared residuals. Sorry, ini-square natin mga residuals. Squared, no? Square siya mga yan, ha? And then get the sum of that, and then that will be your, that will give us the parameters. Okay. Okay? All right. Then ito, no? Take a look at this. The slope of the coefficients has the same sign as the correlation coefficient. Okay, so for example, kinuha natin yung correlation ni x at saka x1 at saka y. Tapos ang correlation nila, let's assume that ito yung plot ng x at saka y. So this is your y, this is your x. Pag kunin natin correlation nila, yung r of x and y, you'll be sure that it's negative. Negative, no? Okay? Kasi, di ba, downward yung trend. All right. Now, when we do the regression line, tapos let's say si beta 1 is the parameter for x1, no? The sign of this will also be less than 0. Okay, si B1 negative din siya kasi ang correlation ni x at saka y negative. So expected na si coefficient will be negative. Okay. Once again, class, paki-chat nga kung okay tayo so far. Okay. All right. Thank you. And ito, minention ko na to kanina, no? The sum of the residuals is 0. Okay? Kaya nga, ang kinukuha natin yung squared residuals. Okay. All right. So, okay, parang alanganin, no? Sige, at least ma-load muna natin data natin. Okay. Now, we're going to make use of certain packages like psych package, pastex, OLSRR, Stargazer. Okay, and you know already that in order to install a package, diba? Install that packages, then pwede natin i-see, sabay-sabay, pwede natin i-concatenate, see, yung mga to. No? Oops, nakopya ko yung install. So, merong coach dyan. Okay? So, lahat yan. And then, pag mag-library tayo, class, one at a time, hindi pwedeng sabay-sabay. Okay? So, ilo-load si psych package, si pastex, si OLSRR, and Stargazer. Okay, there's another quick way to load packages na hindi na tayo mag-i-install that packages pagkatapos library. Kasi after we install packages and then library na. No? Okay. We're going to make use of the pacman package. So install that packages muna, pacman, all right? And then of course, i-library nyo to, pacman. Okay. Once we have installed pacman, we can make use of this now. From the pacman package, we can use the pload. Okay, pload. Control C, Control V. All right, pload na na function. Okay, if in order for you to check si pacman, almost time na no. So we can use the help dito. Double question kasi package to, or you can just use the package. Okay, gamitin ko na to, pacman, and install it here. Pero pakita ko lang muna class. Ng pacman, if I click this, yan, ito yung mga functionalities niya. So this is, para sa batong pacman package, tingnan natin itong description. This is for tools to more conveniently perform tasks associated with add-on packages, etc. So this is a generic tool, no? Para mapabilis lang yung yung mga different functionalities in R. So just this last. Okay, so pag na-install niyo si pacman, then actually hindi niyo kailangan i-library. No? You can go straight here. Pacman pload. Okay, so what will this do is it will i-install niya yung mga packages na to, tapos kasama na yung pag-library. Okay, so kindly try this at home, kindly try this on your own, and next meeting make sure that these packages are already loaded on before Monday, before our class. I'm also going to give a second RMD file kasi next meeting matatapos natin to, so dapat itutuloy natin to. Please bring the document. Hindi pa natin nasi-save to. Next meeting. Okay, so let me pause for a while. It's already time. So are there any questions? You may ask your questions now. Okay, if not, okay, I'll see you on